Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever, and we're still building the MachO reader. I was thinking that maybe in the here in the parsing we should also maybe here, if not is pure virtual, base is pure virtual. Here, we should probably put an assert here that implicit is false. Okay, so I was thinking here on the getBase class, maybe we should have the index in the same order. What if we can index by the leaves? So right now the index starts from the top parents and then goes down to the children. But what if the smaller indices actually all start at the leaves? Yeah. I guess it doesn't matter much. It would be better for performance, maybe. It's okay. We can implement it dirty. Yeah. Oh, this will be expensive work. Yeah. How expensive are the other functions by now? Hold on, let me see. So I want to see from here. Let's see, int a 0. Just want to see how expensive this is. And B. I just put it this so I can put breakpoints here. So I got this and this. Okay, so that's the first one. Let's see how fast it roughly is. Oh, that was very fast. Next one. Oh, we got a hit here. Okay, we need to remove that. Okay, so press. Press. Yeah. Okay, that's very. These are actually very fast, these two processes we have so far. So maybe this one will be okay as well. Yeah. So this is not a performance concern, most likely. Okay, so how would we do this? We need to walk. We need to walk the primary vtable here. And then compare it against every yeah. Oh, this will be expensive. Oh boy. I would say we walk. We have vtable UN16T vtable index. Do we call it vtable index? Yeah. Vtable index 0. And then we do Mm. Mm. Hmm. 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 Yeah, I would say then here we walk for vtable entry in vtable. Somehow this is not working. And then here we have a base class index, classes, class index, class, base class type. I think we can make this const. On that note, maybe we can also make a bunch of things const here. Base entry. This can be const. Entry. This can be const. Why is this complaining? vtable dot entries. Yeah. And we say here if base class type dot vtables dot empty continue. Base class type base class and then we say for vtable vtable. Why don't we just put this guy? We can put it down here, right? And then we put vtable, base vtable, base class type m vtables dot front. Note, this function is probably a bit more expensive than it needs to be. It's likely more expensive than it needs to be. Vtables front, base vtable. What's the problem here? Why is it complaining? Const. Okay, so for this, and then for this, base vtable dot m entries, and then we say if vtable entry dot is first declaration, and then we do get function name. No, make function name, find function name. Why is it find function name? Find function name. How about we rename this to get function name without class name. Get function name without class name. Or without context name. That's without class name. Here we make function name with new class name. I think that's a bit more explicit what is happening here. Yeah. Okay, let me say here get function name without class name. vtable entry dot mname std string view so, how do we call it? Entry function name. Let's take this here. Actually, we need to take This one should be called entry and this one base entry. If base entry is first declaration, then get function name without class name. Let's remove this. Okay. And then we do the same check. Pure virtual. No. I think we need to take this guy here. And we say assert entry dot is first declaration, not, yeah, and then but this one is a problem. Actually no, we can say, we say if entry dot base class index is not invalid index, then continue. Already set. Continue. Yeah. And if entry dot if is first declaration, then we can also continue, which means that we can remove this assert. And so if this case is true, then here we break. And we set entry dot base class index to base class index. Yeah, I think that's the implementation for this. It's quite a heavy loop, I think. Yeah. Yeah. Because it needs to visit all base classes, and then it needs to go through all of these and all of these. Yeah. So it will be a bit of work, I think. Let's see how it looks. Yeah. As long as it works, I think it's fine. It's a bit convoluted, I would say. But it's reasonably simple to understand, I would say. Yeah. Okay, so base class index, basically this one just counts up as long as we get some base class. But this one doesn't seem to have a base class. It does. Why is this returning nothing? Well, that's unexpected. Base class count is 1, index 0. Oh, I see. Return. There we go. Ah, hold on. Base class here, return here. There we go. Okay, so base class index is 0. We get something here. Base class memory pool object, blah, 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 blah. Is first declaration, yes. Is destructor overwritable. How expensive is this function? Why don't we cache this information? Yeah, I don't understand. Why don't we cache this? Can I have a bool here is destructor. Where are these set here? Let me see. Is there any reason? Where's this set? This is set. Oh my gosh, it's not finding it. What about this one? Also not finding it. Jesus Christ. This one is set on parsing songs. Okay. So it should be known right away. Then I think what we should be able to do is bool M is detour. False. Virtual function is destructor. And then vtable entry thunk index vtable entry dot m is detour. We do m thunks dot m is detour. There we go. And here is pure virtual. Here we do vtable entry. Is detour is pure virtual, and here function. So here we would say vtable entry dot m is detour equals m functions dot m is ctor or detour. Yeah. And that way we don't need that unholy function anymore, this one. We can remove this. This. And then we need to entry. Then we can simplify this to entry dot m is detour and base entry dot m is detour, and then we can remove these guys. By the way, what about this pure virtuals m classes? Yeah, okay, that's greatly simplified. And then here we can do the same. Entry dot m is detour base entry dot m is detour. Then we can remove this. And I think we can also make this static, this function. Static. This one can also be static then, if I'm not mistaken. Static. What about this one? No, this one probably not. Okay, and then we can also simplify this. Entry dot m is detour base entry dot m is detour. Yeah. I wonder if we should just check this first and then return that, and then afterwards go here. process primary. We can just call this function now. We can where's this called? 1, 2, 1, 2. We can make a new function. So process primary vtable entry. Process. So instead of this one, we will make a vtable entry is override. Vtable entry and then we remove the class type and we make both consts. Okay, and then we put that here. And then we take this, I put this here, and we remove this. So basically it's now just checking. Then we can remove this function here, and then we call this, and then we call this here and here, and then we call vtable entry is override. We call this here, and we remove this and this. Okay, and now we have a reusable function here that we can use here. If is first declaration, if vtable entry base entry, if that's the case, then we do this, and then we can remove this. There we go. Yeah. Yeah. Okay, let's try this. All right, so. Um, I wonder if there's a way to like reduce the things to check. Like, for example, here, like we now start at index 1 again, at the first element. Is that really necessary? Maybe we could save. Is first declaration. It is first declaration. Okay. First declaration. Yeah. Body module. Vtable entries 84. How about, let's step through a bit. What do we have here? Okay. So this one is an override. Okay, it's not the first declaration, that's why. Okay, that's good. So this class has more base classes. Yeah, it's a really expensive run here, but it's probably still very fast for us. Yeah, I think it's fine. Okay, so let's put let's actually, how about we say if not is first declaration, then we continue. Then we remove this. If not is override, continue. Okay. Okay, let's put some breakpoints in here and in here and in here. And let's check those. Let's see if these guys are hit here. I would expect that all of these can be hit. This one here probably only with destructors. Okay, so this is not first declaration. Okay. Vtable entry is override. Idle. Idle, idle. changed. This will hit a lot here. Okay, this one is probably, yeah, destructor. Oh, this as well. Oh, right, yeah. Okay, so basically at the end of, there's probably some ways you could optimize this, but I suspect that we don't care. So what we can probably do is here at the end of it, here assert, let's do if entry dot is, if entry is not first declaration and entry dot base class index is invalid index, then int invalid index or missing base class index count plus that. So this one should never hit when this is done, right? If it is, then something could be wrong. Let's see. Let's put a breakpoint here. I want to see how fast this function is now, just by eyeballing it. So I press F5 and yeah, it takes 100, 200 milliseconds or so, I would say. Yeah, maybe 300, 400. I think it's more expensive than it really needs to be, but I mean, we don't really care. It's debug and it's not performance critical, so I think it's fine. As long as it's correct. Okay, so let's see if this hits, and it does. Oh. Science info is detour is override, and it doesn't have a base class index. Huh. Yeah. How is that possible? Science info. Science info. Idle. Oh. Seems to be everything here, no? I mean, it looks like it is everything. Base class index. Why is this not set? Do we create a copy or what is going on? Huh? Okay, let's see the first one. I don't understand. Probably some stupid reason. Yeah, it's like 200, 300 milliseconds or so. Entry, science info. Okay. Then let's see here. If class type dot m name equals science info. Let's see what's going on here. Tests. Put a breakpoint. Okay, let's see. Vtable 2 entry base entry is override. Yeah, but this one also has base class, right? Yeah. Okay. Continue. Continue. Okay. Okay. Next, null. Oh, why is this returning null then? Okay, I think that's a problem. This returns null. Let's look at it. Why is this returning null? We have base class is 1, count 1. So it goes in here. Oh. No. Index I 0. Smaller count. Base classes 0. Class type overridable. And then it will be child classes index minus 0, index minus 0, index 1. Oof. Okay. Index minus 1 index. Right. Index. Yeah, something is not right here. Yeah. Index 1. I think we have to give it index 1. Could be, do we have to give it index index minus count. Index minus count. Could that be? Maybe. Index minus count. That means we need to assert that count is larger equal index. Okay, so okay, so this one fails, and basically we put another breakpoint here. So this is now the next one, index 1, and now we hit count 1, and we go down here, class type count, and now we have index 0, count 1, index. Okay. Okay, and then it should now find the entry. Ta-da, entry, there we go. Oh, there we go. There we go. Okay, so this works now. And we get an error. And I knew it. I knew it. Okay, what do we have now? Count must be bigger. Index must be bigger than count. Yeah. Index larger than count. And we still have a hit. Counter measures behavior. Is sub objects upgrades? How many do we get? Two. Just two. That's not much. Let's see why. Just two. Okay, counter measures behavior. Counter, oh god. How is this written? Copy value. Let's put this breakpoint here. Counter measures behavior. Ta-da. Put the breakpoint here. Wait, what was the full function name? Okay, How about we put breakpoint here if entry.mname is that int a equals 0. Put a breakpoint here. Test. mname. Good. So this one is somewhere. Countermeasures. Let me see. Countermeasures. It's an override. It claims it is an override. So the base vtable here. What is it? Is sub-objects upgrades. Is sub-objects upgrades. Is... I don't see it here. Is sub-objects upgrade. Sub-objects upgrade. Let me see here. Oh boy. Type vtable. Vtable for this. So we're looking at is sub-objects upgrades. Is sub, it's here at the very end. The very end is sub-objects upgrades. Okay. Oof. Oof. Countermeasures behavior interface. Countermeasures behavior interface. Countermeasures. Countermeasures behavior interface. Let's look at this one. Oh. Just pure virtuals. Oof. 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 But it is marked as countermeasures, base class, base class, base class. Okay, so we know that in here there is nothing. Yeah. There's nothing. What about the next one? Upgrade MUX. What? Upgrade MUX. Is sub-objects upgrade? There it is. It's a pure virtual. It's implicit. So this one, continue, continue. Yeah. Is override. Upgrade implementation, continue. Yeah. Yeah. Let's see the next one. Countermeasures behavior interface is active, it says. Report missile for countermeasures, calculate countermeasures, reload countermeasures is active. Do we already have this in Thyme? Countermeasures behavior? Countermeasures, countermeasure. Yeah, interface we have at least. It says is active, yeah. F5, next one, 48. Behavior, get countermeasures behavior. Next, 2. Update that. Nope. 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 That's it. Then I don't really understand why is it an override. Maybe it's not an override. Is override. Maybe is override is incorrectly set. Could that be? It's implicit. Let's check one more times. So it's here is sub objects upgrades. Okay, let's search for this in here. Is sub objects upgrades. Okay, we have it here. Okay, so the pure virtual is an upgrade module interface. Upgrade module interface. Which is a child of upgrade MOOCs. Why is it not reaching that? Upgrade module interface. Upgrade module interface. Let's restart. Upgrade module interface. So, upgrade MOOCs. There we go. So here we will have is already upgraded. Attempt upgrades, wood upgrades, the reset upgrades. There we go. Is sub is sub objects upgrade. So it is not the first declaration, so that's why it will fail. It's an override. No, it's implicit and pure virtual. Continue. Good. Okay. Yeah. Yeah. Okay. Now we are base class index 1. So now we get the next one, and the next one is count 3, index 2, base classes. So now the next one is here. 2. Okay, so now it visits this next one, which is countermeasures behavior interface. Yeah, let's put a breakpoint here. So now we look at 3. Behavior module. Wait, which one do we want? Upgrade module interface. Upgrade module interface. There it is. Upgrade module interface. It is there. vtable is 1. But it's not there. Upgrade module interface. Update and get disabled types to process. But here it looks different. What? Okay. Okay, that I don't understand. This one looks completely different. Upgrade vtable for that. There we go. One, two, three, four, five, six, seven. 7 pure virtuals. Which matches this here. 7 pure virtuals. But update module. What? Why do we have only 2 entries here, which are completely different? Update. Huh? Okay, update module interface. So somehow, parse vtable. Update module. Tests. Update module interface. Let's check it. There we go. Blah, 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 blah. Vtables and place back. Vtable. Okay, what do we get here? Okay. So there's a pure virtual. Okay, so we push back a pure virtual. Okay, that's fair. What's next? Looks like we have another pure virtual. What's next? Just 2 pure virtuals. Why? There are more than 2. What? So we now have 2 entries. I don't get it. Address 804.560 560 5 what? 804 560 804 what? 804 560. Huh, there are only 2. What am I looking at? Update module interface. Are there 2? Huh? What is this thing here? Oh, this is update. We're looking at upgrade. Upgrade module interface. Oh boy. Not updates. Oh boy. The noobness. Absolute noobness. There we go. Upgrade. Let's see what this one has in store. So that's 1 pure virtual. That's another one. That's another one. I think we expect 7, right? That's another. And 6. And 7. And we are done. 7. Yeah, that looks correct. Okay, then what is the problem now? So we have 7 pure virtuals, an upgrade module interface. What's the problem now? Countermeasures. Here. Base class countermeasures behavior. Base class type. Update module. But we're looking for upgrade module interface. Update module. Upgrade MOOCs. behavior module, update module interface, object module, behavior module, module, memory pool object, snapshot. That's it. Ugh. Why is there no upgrade module interface? Let me see. Let's go back. That's weird. Let's go to upgrade MOOCs, and then we look at that. Upgrade MOOCs. Here, upgrade MOOCs. This one has one base class, yeah, and 3BD, 3BD, 0x3BD. That's upgrade module interface. Why is it not going in there then? Then that means there's an error still here in this, in here, no? Yeah, I think it skips certain positions because the index, yeah. I think this function is wrong still. We should probably implement it differently then. How about we say we go into all, we first go into a hierarchy. Let's remove this here. Oh boy. Yeah. We can go first to all the leaves. Maybe. Yeah, how do we deal with the index? Not sure. Index. I think the issue with the current implementation is that there are multiple paths where the index will be the same. And so there's probably a case where, yeah, some index is double mapped, and that's why it's hidden, and you can't get it with a unique index. Yeah, we need to have like a way to get. It's because our implementation of our base classes is not flat, and it's hard to get it. Maybe we should. Maybe the base class. Maybe the base class should also be. Well, that won't help. That won't help, no. Boy. Oh, boy. How about we think about it in the next session? I don't know right now, but there's probably a simple way to do this. Yeah. I will take a break here. The next session we look at this again here. Yeah. All right. Then have a great day or night. Until next time. Goodbye.